Earth is sometimes known as the blue marble. Imagine for a moment if Earth was flat. After all, many believe in this archaic theory. So, how would one go about their daily routine if Earth was really flat? Because Earth is spherical, its gravitational pull on things is the same no matter where they are located on the planet. For Earth to adopt the form of a flat disk in the first place, the force of gravity, as we now understand it, must be completely ineffective. It would quickly transform the globe into its original spheroid shape if it occurred. According to calculations made by the mathematician and physicist James Clerk Maxwell in the 1850s, a solid disk like Earth would not be viable under actual gravity circumstances. These findings led to a speculation that a flat Earth would not have any gravity. On the other hand, if the Earth is flat, gravity may draw everything toward the disk's center, which would be the North Pole. According to James Davis, a geophysicist at the Lamont-Doherty Earth Observatory at Columbia University, in this hypothetical situation, the more away you are from the North Pole, the more horizontal the gravitational push toward the center point of the disk will be. This conclusion was reached by examining the relationship between distance from the North Pole and the angle of the gravitational pull. And this would cause chaos all around the globe. But at least it would be simple to break the world record for the longest leap, as long as you made sure you were facing north before you started jumping, of course. A flat Earth model would be incapable of supporting the layer of gases known as the atmosphere if gravity were removed from the equation. The light released from the sun would no longer scatter when it hits the Earth's atmosphere, which gives the sky its signature blue color and makes it recognizable to humans. Without this protective blanket, the heavens above the Earth would be pitch dark. According to an article published in BBC Science Focus by Luis Villazon, a biologist and educator, the loss of atmospheric pressure would expose plants and animals to the vacuum of space, resulting in instantaneous asphyxiation. If the plant did not have an atmosphere around it, the water on the surface of the planet would immediately begin to boil away in the vacuum of space. This is because water begins to boil when the pressure of its vapor equals that of the atmosphere. Hence, a lower atmospheric pressure results in a lower boiling point. If the planet did not have an atmosphere to assist in retaining heat, the temperature on its surface would fall, which would cause any residual water to freeze swiftly. However, deep-sea creatures that don't rely on oxygen to live, such as chemosynthetic bacteria, can make it through this change. If gravity tugged toward the center of the planetary disk, which in this instance is the North Pole, precipitation would likewise tend toward that location. This is owing to the fact that precipitation falls to Earth as a result of gravity, and, as a result, will fall toward the location on Earth that has the largest gravitational attraction. Only in the very center of the disk would the weather act in the same way that it does on Earth, which is to say that it would fall in a vertical direction. If you drive farther away from the coast, you will notice that the precipitation becomes more horizontal. According to the Lamont-Doherty Earth Observatory at Columbia University, water in rivers and seas would likewise flow toward the North Pole, and this would result in massive bulging oceans collecting in the center of the world, leaving almost little water at the planet's boundaries. Not only should we anticipate navigational challenges without GPS, but also longer journey durations because of the greater distances we would be required to cover. The Arctic is said to be located in the middle of the world, while Antarctica is supposed to create a massive ice wall around the planet's perimeter. This wall, which neatly prevents humans from falling over the planet's edge, is the basis of the flat Earth idea. However, if you cannot fly around the world and must instead fly across it, the total time it takes to complete a journey will considerably rise. For instance, if you wanted to fly from Australia, which is on one side of the flat Earth map, to a McMurdo station in Antarctica, which is on the other side of the world, you would have to fly over the whole Arctic, and both North and South America. If the Earth is flat, instead of being divided into two hemispheres as it is on the spherical version of our planet, the order of night and day would remain the same regardless of whether or not you were in the northern or southern hemisphere. If this were the case, then going stargazing would be a lot less of a hassle since you wouldn't have to cross the equator to complete all of the items on your astronomy bucket list. But we would be missing out on many of the ground-based discoveries that have been made because we have access to a 360-degree perspective of the visible cosmos from Earth. We would all see the same thing if we had the same view of only one section of the night sky. And to get a more comprehensive picture of the universe, we would have no choice except to depend entirely on telescopes located in space. Hurricanes, which also may be named typhoons and cyclones depending on the region in which they occur, are responsible for an extraordinary amount of damage each year. According to NOAA, Hurricane Harvey was solely responsible for causing $125 billion in damage to the United States in 2017. The Coriolis effect of the Earth is responsible for the destructive revolving nature of these tropical storms. And this force causes storms in the northern hemisphere to revolve counterclockwise, while storms in the southern hemisphere rotate clockwise. In both hemispheres, tropical storms may be very destructive. On the other hand, there would be no evidence of the Coriolis effect on a motionless flat Earth. Without Coriolis force, there will be no hurricanes, typhoons, or cyclones will exist. According to NASA, the amplitude of the Coriolis effect is 0 near the equator, which is another reason why we do not witness storms of this sort between 5 degrees north and south of the equator. Satellites would have a difficult time circling if the Earth is flat, hence, it is possible they would not exist. I cannot think of how GPS would work on a flat Earth, said Davis, a geophysicist at Columbia University's Lamont-Doherty Earth Observatory. There are a number of satellite missions that society depends on that just wouldn't work, added Davis. We rely on Global Navigation Satellite Systems, GNSS, for everything from GPS services on your phone to information about travel, and just-in-time inventory management in grocery stores to ensure that product is delivered as promptly and as fresh as possible. And, most importantly, emergency services utilize GPS to identify callers based on their phone signal. Hence, satellite communications have the potential to save a person's life. It is difficult to picture a world without GPS. It is sufficient to suggest that we would be completely disoriented. On the bright side, if humans lived on a flat Earth, we would at least have horizontal rain to help us find our way in the right or north direction. NASA says that the moving molten metal around Earth's iron core creates electrical currents that, in turn, make the magnetic field that protects the planet and goes from one pole to the other. But if the Earth were flat, there wouldn't be a stable core to make a magnetic field, so that protected layer, called the magnetosphere, would disappear, and auroras would too. Even so, the lack of auroras would be the least of our problems since Earth would no longer be safe from solar winds. NASA says that dangerous radiation from the sun would hit Earth and everything on its surface, leaving a barren world like our friend Mars. So, would you prefer Earth to be flat? Join the conversation and let us know in the comments below. Did you learn something new today? I hope so. If you did, give this video a big thumbs up and share it with your friends. You can also subscribe to the channel to avoid missing any of our future videos. Thanks again for watching, and I'll see you next time.